In today's video, I want to introduce you to a logarithm. We've had a lot of experience in the world of exponents. The logarithm is sort of like the opposite of an exponent. So with an exponent, we say, we have a number here, x, and we multiply it by itself a times to get b. Or here we have a numerical example. We have the number 3, and we multiply it by itself twice. So here we have, let me write that down. Here we have 3 times 3. That's a different color actually. And I need to make my brush thicker. Let me make it like that. So here we have 3 times 3. And there's 2 3's. 2. And that's equal to 9. So we're saying 3 multiplied by itself twice is equal to 9. With a logarithm, we're saying, what power do we have to raise 3 to? How many times do we have to multiply it by itself to get to 9? And our answer is 2. Similarly, over here, we have an algebraic example. We say x times itself a times is equal to b. But with the logarithm, we're asking what a is. How many times do we have to multiply x by itself to get a? Here, let me run you through some examples. So let me change the color. Okay, so here we have, and I'll teach you the proper way to say logarithm base 8 of 64. So you say the logarithm first, and this number is called the base. And this number, and you say of, so logarithm base 8 of 64. And what is that equal to? So 8, let me scroll up a little. 8 to what power is equal to 64? And if we memorize our squares, we know that 8 squared is equal to 64. So this is saying that 8 times itself 2 times is equal to 64. Let's do more problems. So here we have logarithm base 10 of, let's say, 10,000, sure. So how many times do we have to multiply 10 by itself to get to 10,000? And we can just count the amount of zeros, 1, 2, 3, 4. So 10 to the 4th is equal to 10,000. So our answer is 4. So logarithm base 10 of 10,000 is equal to 4. Let's do 2 more examples. Logarithm base, let's do a hard one. 3 to logarithm base 3 to the 27th. So 3 times 3, how many times so 3 multiplied by itself, how many times is 27? So many of us don't know that, so let's work through the problem. So if we just multiply 3 by itself once, we just get 3. If we multiply it by itself twice, we get 9. And if we multiply it by itself 3 times, we get 9 times 3, which is 27. So our answer is 3. Oops, I circled that bad. Our answer is 3. So log base 3 of 27 is equal to 3. Let's do one more. And I'm going to write it differently this time. So let's do, you'll see what I'm doing in a bit, 2 to the x is equal to, let's say 32. Sure, why not? 32. How can we write this in the form of a logarithm to find x? So here we would say logarithm, and what are we trying to find? We're trying to find how many times we multiply 2 by itself to get 32. So our base is 2, and then we're trying to figure out how many times we have to multiply it to get 32. And our answer is equal to, wrong color. Our answer is equal to x. So let's do the same process we did up here, because many of us don't know that. So if we just have 1, 2, we have 2. And then if we multiply it by itself twice, we have 4. And if we do it again, we have 8. If we do it again, we have 16. And if we do it again, we have 32, which is our desired answer. So that means x is 5, because we had to multiply 2 by itself 5 times to get 32. So that means that log base 2 of 32 is equal to 5. Now start thinking about some of the exponent properties and how they can relate to properties of the logarithm. Thanks for watching.